Hello everyone. In this lecture, we will see the whatever the terms we have covered in the multiple linear regression and multiple correlation coefficient and partial correlation coefficient. So first we see the trivariate data. For that we use the three variables x1, x2 and x3. For simplicity, we consider x1 as x1 minus x1 bar, x2 as x2 minus x2 bar, and x3 as x3 minus x3 bar. So according to the property of arithmetic mean, we know some of the deviations of observations from their arithmetic mean is always 0. So for that we get summation over x1 is equal to summation over x2 is equal to summation over x3 is equal to 0. This implies your value of x1 bar is equal to x2 bar is equal to x3 bar. All these terms are 0. For derivation we are using these terms. Then we find the variance of xi. It has the formula summation of xi square upon n, and the x bar term will be 0. So directly we get the formula, that is sigma 1 square has the formula summation over x1 square upon n. Sigma 2 square has the formula summation over x2 square upon n, and sigma 3 square has the formula summation over x3 square upon n. To get the covariance term, we know covariance of xi comma xj has the formula summation over xi xj upon n minus xi bar xj bar. These two terms are 0. So we'll get the correlation between xi and xj. We use this formula, which is equal to covariance of xi xj upon under root of variance of xi and variance of xj. So by definition, covariance of xi xj is summation over xi xj upon n, and variance by taking square root we will get sigma I and sigma j. So in general, correlation coefficient of R12, to get the answer for R12 total correlation coefficient, we get the formula summation over x1 x2 upon n sigma 1 sigma 2. So we use this formula to get the total correlation coefficient. Then we write the correlation matrix, correlation variance covariance matrix. It is denoted by capital R, which is equal to R11, that is correlation between x1 and x2, R12 R13 correlation between x1 and x2, x1 and x3, then R21 R22 R23 R31 R32 and R33. We know correlation between x1 and x1 is 1, so you get R11 is same as R22 is same as R33. All these terms are 1. So finally we get correlation variance covariance matrix as 1 R12 R13 R21 R1 R23 R31 R32 and 1. This is your variance covariance matrix. Then determinant of this matrix, determinant of R, we calculated, which is equal to 1 minus R12 square minus R13 square minus R23 square plus 2 times R12 R13 and R23. Then we find the cofactors of this matrix. R11 has the formula 1 minus R23 square. Similarly, R22 has the formula 1 minus R13 square, and R33 has the formula 1 minus R12 square. Then to get the cofactors R12, we use the formula R13 R23 minus R12. To get the formula for R13, we use the formula R12 R23 minus R13. So in this way we get the all cofactor terms. Then to get the to fit the regression line x1 on x2 and x3, so we use the regression fitting of regression line. X1 on x2 and x3 has a equation. Fitting of regression line, x1 on x2 and x3. So r11 upon sigma 1 x1 plus r12 upon sigma 2 x2 plus r13 upon sigma 3 x3 v is equal to, we solve this for x1. Similarly other terms are there, other equations are there. Then residual is denoted by x1 dot 23, which is the difference between actual value x1 and estimated value x1 cap by using linear equation. Then we find this term also x1 dot 2, so x1 minus x1 cap, this is for only two variables, so x1 minus b12 x2. Then there are some properties of residuals. Then variance of residuals we calculated. Variance of x1 dot 23 has the formula, it is denoted by sigma 1 dot 23 square, and we calculated that formula sigma 1 square upon r11 into determinant of r. This is the variance of residuals. Yes. Then multiple correlation coefficient. Multiple correlation coefficient x1 with respect to x2 and x3 is denoted by capital R1 dot 23, and the formula is under root of 1 minus determinant of r divided by capital R11. Similarly other terms are there. Then partial correlation coefficient. Partial correlation coefficient. It is of x1 and x2 with respect to x3 is denoted by r12 dot 3, and the formula is minus r12 upon under root of r11 r22. These are the important terms we have seen in this in the previous lectures. So here we will see some problems related with partial correlation coefficient and multiple correlation coefficient. So first problem is, if all the total correlation coefficient, problem number 1, if all the total correlation coefficients in a set of three variables are equal to rho, then show that number 1, r1 dot 23 square is equal to 2 times rho square upon 1 plus rho. Number 2, partial correlation coefficient R12 dot 3 is equal to rho upon 1 plus rho. So first we prove the first term. We know the formula for R1 dot 23 square, which is what? R1 dot 23 square has the formula already we write here. Multiple correlation coefficient has the formula under root of 1 minus determinant of R divided by R1, correct? So we remove the square root, so we'll get R1 dot 23 square has the formula 1 minus determinant of R divided by R11. But we know determinant of R has the formula 1 minus R12 square minus R13 square minus R23 square plus 2 times R12, R13, R23. So by putting these values we get the answer 1 minus rho square minus rho square minus rho square plus 2 times rho cube, R12, R13, R23, correct? So which is equal to 1 minus 2 times rho square minus rho square and plus 2 times rho cube. If you take 1 common, what is remaining? 1 minus 2 rho square. And if you take here we can write as it is. For simplicity we use the other terms. Okay, 1 minus in bracket 1 minus 3 times rho square, 3 times rho square plus 2 times rho cube and divided by 1 minus R11, capital R11 has the formula 1 minus R23 square, correct? So which is equal to 1 minus rho square, 1 minus rho square. So if you take this term in this side, so 1 minus rho square minus 1 plus 3 times rho square minus 2 times rho cube divided by 1 minus rho square. So finally which is equal to 1 gets cancelled, 1 rho square, 2 rho square minus 2 rho cube upon 1 minus rho square. So which is equal to, if you take a 2 rho square common, what is remaining? 1 minus rho, and this term we can write as a 1 plus rho into 1 minus rho. So one term gets cancelled, 1 minus rho, finally get 2 rho square upon 1 plus rho. This is your RHS. In this way we can prove that R1 dot 23 square is 1 minus determinant of R divided by R11. One more term is there, partial correlation coefficient. So similarly, same here, use the formula and according to that we can get the answer for R1 dot 23 square. Here we write the formula. R12 dot 3 has the formula minus R12 upon under root of R11 R22. So by putting the terms we get the answer minus in bracket, you know, R12 has the formula R13 R22, that term is rho square minus rho divided by under root of 1 minus rho square into 1 minus rho square, same term. So square root get cancelled, minus in bracket, if you take minus sign inside you will get rho, and if you take rho common, what is remaining? 1 minus rho divided by 1 minus rho square. Same we use here also, rho into 1 minus rho divided by 1 plus rho and 1 minus rho. So the 1 minus rho gets cancelled, which is equal to rho upon 1 plus rho, which is equal to RHS. So in this way we prove the partial correlation coefficient R1.23 is equal to rho upon 1 plus rho. Thank you for watching.